So hey guys, so today we're gonna we're gonna get to the concept of series. Series. So first we gonna talk about the definition of the series. So what is a series? So series is a um, sum of terms of a sequence. And so on your calculus two courses, you're gonna mainly deal with the infinite series. Um, that is mean that um, the infinite series. It's mean that for example, you have like you have the sequence of a sub n, and then you have to calculate the sum of a sub a1, a2, a3 plus plus a sub n and plus etc. And it's gonna and this sum gonna call the infinite series, right? Because you have the infinite sign over there, and so that's pretty much about series. This one is infinite series. So now consider the sequence of 1, 2, 3, 4, and etc. So what we call this sequence, we call it arithmetic sequence. And for the sum of the of this sequence, 1 plus 2 plus 3 plus 4 plus da 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 plus and plus da da da. So you see that so if this one is a infinite series, it's gonna diverge because it's get really large when when your n is increased, it's gonna get really large and it's gonna diverge. It not converge to any finite number, so that's why we call it diverge. However, now we consider a sequence of 1/2 to the power of n. So what we call this sequence, we call this one is geometric sequence. I will make a another video about geometric sequence because it is a large part of a series, so I will make a video about that. And so why we call it a geometric sequence? Because for a geometric sequence, it's opposite to the arithmetic sequence, because you see the difference between each term right here is one unit different. So so this one is like plus something between two consecutive terms. So geometry will be like kind of opposite, because you have to, because the difference between two terms gonna be multiplied by some number that we call common ratio. So in this case, what is the common ratio? And it's gonna be 1/2, because when you expand this sequence out, starting from n equal to 0, it's gonna give you 1, and then 1/2, and then 1/4, and then 1/8. You see that? So the difference between is like you have to multiply by a half to make a next term So you see it, yeah. So for arithmetic it's gonna be plus, and for the geometry it's gonna be multiply. And so you agree with me that the common ratio gonna equal to 1/2, right? And then we call another term, we call a, and it's gonna be our first term. We're gonna definite give it a definition. A is gonna be our first term. And what is our first term in this case? It's gonna be 1, right? So a equal to 1. So you have the two key components of the geometric sequence, and it is the common ratio in the first term. So I'm gonna go ahead and give you a formula of this one. So actually there is two cases in geometric sequence. The first case when the actual value of your common ratio gonna less smaller than 1, and your series gonna converge. That is something you need to know. And then on the opposite side, if your absolute common ratio gonna greater or equal to 1, it's gonna give you a diverge series. So and so diverge, we know it's diverge, and it's not gonna convert to any finite number, but for the convergence series it's gonna converge to a finite number. Yeah, it's really obvious. So we have to determine, in some problem it's gonna ask you to determine that finite number. And the finite number, how can we find it? So um so I'm gonna give you the formula to find it. So if we have if we have if we in this case, and our series um our series would be equal to the first term over 1 minus r. And so we apply to this sequence, we apply to the sequence that we use as this example. So sigma of 1/2 to the power of n equal to 0 to infinity, it's gonna equal to 1, because a equal to 1, and 1 minus the common ratio, and it's gonna be 1/2. And it's give you the answer of it's gonna give you the answer of 2. Okay, all right, so it's gonna give you the answer of 2. Yeah. So that's pretty much about Siri. And on the next next video I will tell you more about the geometric series. Yeah, thank you for watching.